Here we're going to get into our different families of nonmetals. These are named, the families at least, are named after the element on top of the table that everything falls into. So the first element in their group is what they're named after. Not all of the elements in these groups are considered nonmetals. So we are just going to focus on the nonmetal ones in this group. Normally, our metalloids are kind of on a staircase type structure, so anything that is after the elements that we talk about in this slideshow are not considered uh, non-metals. They will be metalloids or even getting into the metals in the mixed groups there. So our first is carbon. Carbon is going to react by gaining, losing, or sharing 4 electrons. There is a lot of carbon in our world. It is the most abundant element on our planet, and therefore it is very easy for carbon to find another carbon that will take 4 electrons. So carbon has the ability, because it can gain, lose, or share 4 electrons, it can combine with itself a lot, and we get a lot of different forms of carbon based on what it is combined with and how it combines. Carbon is considered the building block of life. Without carbon, we would not have living things. It is the most abundant element in your body, and it is the most abundant element in all living uh, organisms. It uses a wide variety of different, well, it has a wide variety of different uses in our world. One thing is fossil fuels. All fossil fuels are coming from organic life and therefore are coming from carbon. So this includes oil, this includes coal, this includes natural gas. Any product that is made from those. For example, you make plastics from oils, so therefore all plastics are mostly carbon. Clothing comes from natural materials, therefore clothing is mostly going to be carbon. Carbon is just found everywhere. Most abundant element on our planet. Do not confuse that with the most abundant element in the universe, which includes everything outside of our planet as well, and that would be hydrogen. Our next family is the nitrogen family. Nitrogen is going to react by gaining or sharing 3 electrons. So keeping in mind our Bohr's model here, I want nitrogen here to be happy with its outer shell filled. And again, our first one only gets 2 electrons. Our second shell gets 8. Right now it has 1, 2, 3, 4, 5. So it needs to get 3 more in order to have 8 and make that outer shell happy. So it wants to either gain or share these three electrons with something else in order to become a stable, and will combine with anything that will let it do that. Our biggest two we want is nitrogen and phosphorus, sorry, nitrous. Nitrates and phosphates are probably what you're used to hearing as our fertilizers and stuff like that. But this is nitrogen and phosphorus. Nitrogen, which is N2, which is combined with itself. In that case, it's going to share those 3 electrons. It actually makes a triple bond in doing that, each bond for each electron. Is going to be making up about 80% of the air. That nitrogen in the air, when it's combined with itself, is very unreactive. So keeping in mind with that. Nitrogen is a diatomic molecule. Diatomic molecules are molecules that are made of 2 atoms that are the same. So here I have nitrogen bond with nitrogen. Your body needs nitrogen in order to survive. However, it can't break the nitrogen that's in the air. So we do rely on things that can do nitrogen fixation or nitrogen fixers, which we talked about last year, if you recall, in protists and fungus. Certain protists and certain fungus and bacteria even can fix nitrogen or break that triple bond and therefore provide nitrogen unbound to something for your body to use. You also find these in fertilizers. Phosphorus is very reactive. You can find that in match heads. So the heads of your matches or wooden matches or even paper matches have phosphorus in there, and therefore we just using the friction of it can combine it with the different elements in the air and produce a flame. Moving on is our oxygen family. This is oxygen, sulfur, and selenium, I guess, I think. I'm not sure what Se is. You should look up Se. I'm forgetting what Se is. But oxygen is found as a diatomic molecule as well. That's the oxygen you breathe. It can also be found as a triatomic molecule, which is O3, and that is ozone. You might hear about the ozone layer protecting us from harmful rays of the sun, or you might even hear about the hole in the ozone layer that is forming over Antarctica. But oxygen, again, gains share 2 electrons. Oxygen family, we have sulfur. Sulfur smells like rotten eggs and is used in manufacturing of rubber. You also have sulfuric acid, which is a very powerful acid. It's close to a 1 on the pH scale. Um, Moving on to our halogen group. Our halogen family are our salt forming. So anything in our halogen group, which is below fluorine, is going to be used for making salts. When they are uncombined, they're just by themselves, they are actually going to be quite poisonous to you, as opposed to when they are combined into a salt form, such as chlorine there, being combined with sodium to form table salts, then it's not actually poisonous. In fact, you actually need it to live. A lot of times you will use chlorine in pools and developing photograph film, if anybody still uses film these days. And again, just a reminder, fluorine is your most reactive element on the table. Our last group is the 18th group, which is our noble gases. They do not gain, lose, or share electrons because they are unreactive. They just don't react with other elements. Their outer shell, according to Bohr's model, that outer shell of electrons is full and therefore doesn't want to gain them. It doesn't want to lose them. It doesn't want to share them. It's happy with itself. So your examples of that are like your neon. You find in your neon signs. Neon is just the orange part, and this orange is red is neon. These other ones you can either get by adding other elements to neon, or you can use your other noble gases to create the different colors. Hydrogen is our last non-metal. It kind of gets its own group by itself. It makes up 90% of everything. So it is the most abundant element in the universe. However, it's only 1% of Earth, because again, Earth is mostly carbon. Most of it is going to be found combined with other things, and it does not really belong into a group. It's kind of off to itself in the side. It is the most basic of all elements, being number 1, having an atomic number of 1, meaning 1 proton, therefore 1 electron. So most of the time it's just 1 proton and 1 electron. Occasionally you get a different isotope of it by putting a neutron in there, but for the most part hydrogen is just 1 electron and 1 neutron and gets off to itself.